All animals are equal, but some animals are more equal than others. This famous slogan from George Orwell's novel Animal Farm captures the current state of affairs in nature conservation quite well. Though conservationists are uncomfortable admitting that we might have to let some animal species go extinct, they also know that it is impractical to try to distribute their efforts evenly. This makes prioritizing inevitable. Every organization involved in conservation does it, and many focus on the same species, the cute and the colorful, the ones we feel emotionally drawn to. As a result, most mammal conservation projects target charismatic species like the panda and the tiger, leaving 3/4 of endangered mammals unprotected. Birds suffer a similar bias, and other life forms rarely appear on the radar. It is political and economic too. If we want to assign conservation time and money more efficiently, we have some hard choices to make. Even identifying the species in most trouble isn't straightforward. In the past, they were more likely to be the high-profile animals that still get a lot of attention today. When hunting was one of the main threats of extinction, the species at greatest risk tended to cluster together on the tree of life. Carnivores wearing fashionable fur coats or large, tasty herbivores, some with attractive horns or tusks. As global warming takes over as a main driver of extinction, however, this pattern is changing. Smaller animals may be more vulnerable to climate change than they were to hunting, says Jonathan Davis at McGill University in Montreal, Canada. And once ecosystems start to collapse, extinctions may appear at random, a classic signal of mass extinction. Today, the Red List of the International Union for Conservation of Nature provides a catalog of the extinction risk faced by as many species as possible. But with 4,000 listed as critically endangered, just one step from extinct in the wild, it still leaves the enthusiastic conservationist with a vast range of choices. One solution might be to focus on areas that are home to the largest number of species, so-called hotspots of biodiversity. However, this can be surprisingly contentious. For a start, it isn't always clear what counts as a single species. Where an individual species has recently and rapidly diversified into a large group of closely related species, these may not be valued as highly as more distinct species. Likewise, when scientists successfully argue that their favorite species should be split into two or more, some conservationists consider the resulting species or subspecies to be less important than long-established ones. Then there is the problem of judging which hotspots most need protection. It isn't as simple as measuring overall reductions in biodiversity. Although biodiversity is decreasing globally, Maria Dornelas and Anne Magren at the University of St. Andrews, UK, found that on a smaller scale, it is increasing in the sites they looked at almost as often as it is decreasing. But rising biodiversity isn't necessarily a sign that an area is thriving. It may be due to colonization by alien species that do well in rapidly changing or human-made environments. Maybe instead of counting species, we should be looking at the larger branches of the tree of life and trying to preserve regions with high evolutionary diversity. In the early 1990s, Dan Faith of the Australian Museum in Sydney devised a way to measure diversity using phylogenetic trees, a sort of evolutionary family tree where the length of the branches represents the years of evolutionary history separating the species. It occurred to me that if you were to take such a tree and add up the lengths of the branches connecting all the species in a region, that would give an idea of what I decided to call its phylogenetic diversity. The longer the distance, the higher the diversity, says Faith. Maybe instead of counting species, we should be looking at the larger branches of the tree of life and trying to preserve regions with high evolutionary diversity. In the early 1990s, Dan Faith of the Australian Museum in Sydney devised a way to measure diversity using phylogenetic trees, a sort of evolutionary family tree where the length of the branches represents the years of evolutionary history separating the species. It occurred to me that if you were to take such a tree and add up the lengths of the branches connecting all the species in a region, that would give an idea of what I decided to call its phylogenetic diversity. The longer the distance, the higher the diversity, says Faith. What's more, phylogenetic diversity could boost conservation by creating a source of national pride. The government in Australia is quite interested in this measure, says Faith. Nothing that, with its kangaroos and other unusual animals, the country scores high on phylogenetic diversity. They would like to add a biological dimension to the notion of what we inherit from the past, so that we might strive to protect not just our cultural heritage, but our evolutionary heritage as well. While Faith's approach allows conservationists to compare the evolutionary history contained in entire ecosystems, it doesn't tell us about the evolutionary distinctness of individual species, which are still the main focus of many conservation efforts. That's where the Zoological Society of London comes in. Its researchers have been busy calculating species, so-called EDGE, evolutionarily distinct and globally endangered scores. They first divide the length of each branch of a phylogenetic tree by the number of species at its tip. Then, to assess how evolutionarily distinct any given species is, they simply add up these values starting at the root of the tree and ending at the tip where the organism is to be found. The ED will be highest for those species with a long evolutionary history and few relatives. This gives you a measure of each species' individual contribution to the phylogenetic diversity of a region, expressed in millions of years of evolutionary history, says Sam Turvey at the Zoological Society of London. ED is then multiplied by a number reflecting how globally endangered it is, based on its red list status. The resulting EDGE score allows us to rank animals by phylogenetic uniqueness, as well as extinction risk. The approach has generated top 100 lists of mammals, amphibians, corals, and most recently, birds, on the edge of existence, as the EDGE website puts it. That's not an exaggeration, says Turvey. As soon as we launched in 2007, we found ourselves in the very unfortunate position of having to declare the Yanks liver. Perhaps one day there will be EDGE scores for all life, invertebrates, plants, even microbes. That would be interesting, says Faith. it would also expose the fact that emotional consideration will always play a part in our choices. I don't think anybody would seriously consider giving up on a mammal to conserve a large amount of phylogenetic diversity in beetles or bacteria, he says. As for the human edge score, that is rather humbling. In terms of evolutionary distinctiveness, we don't even make the top 1,000, says Turvey. And when it comes to conservation risk, we are in the least concerned category, which drops us even further down the list. Of course, we are a serious concern for conservation, but in a rather different way.